Okay, this is from section 3.4. I'm going to talk just a little bit about the rational zero theorem. First of all, you remember that the zeros of a polynomial function are the x-intercept. They are also called roots sometimes. Basically, there's the solutions to the problem. And you should already know from other conversations that the number, the highest degree on your polynomial is how many zeros there are. That's the fundamental theorem of algebra. Now, those zeros do not have to be real numbers, real zeros, but that should be how many zeros there are. Now, what the rational zero theorem is for, back in the day before we had calculators, we had to have some way of knowing where to start when we were trying to find our zeros. I mean, it's all about guessing and checking, but we needed a place to begin. And a long time ago, someone figured out how for us to at least have a starting point, a jumping off point. So that's where the rational zero theorem comes from. So if this is my function, let's say I have f of x equals negative x to the fourth plus 3x squared plus 4. The degree would tell me, the degree of 4 would tell me that I am going to have 4 zeros. And back before calculators, I couldn't just plug it in and look for my 4 zeros. I had to do synthetic division in order to find them. But I have to have a jumping off point. So I know I have 4 zeros. I need to figure out where I could possibly start. And the way you do that is you take the back number, the constant, and the lead coefficient. And you are going to set up fractions. Now, you're going to take the constant and factor it. So my factors are 1 and 4 and 2 and 2. So those are my 3 factors of my constant. I also have to factor my lead coefficient. Well, in this case, my lead coefficient is just negative 1. And the factors are just negative 1 and 1. Now, honestly, in this case, really you're just concerned with the absolute value of each thing. You don't actually need the positive and negative versions. Because all you are going to do is take each factor and set them up on top of each other. And it's always going to be constant factor over coefficient factor. And it's going to create quite a long list. This one's not going to be quite as bad, but some of them get quite lengthy. So I'm going to take the 1 and set it up over 1. So 1 over 1. And I make it both positive and negative. So that's 2 possibilities. And then I take the 4 and set it up over 1. And that's both the positive and negative 4. And then I take the 2 and place it over 1. So it's both positive and negative 2. So right there I have 6 possibilities. Those are 6 possible zeros. And then you would synthetically divide. So let's do one that's a little bit more difficult, with a little bit more factors. So my function this time is going to be f of x equals 15x to the third plus 14x squared minus 3x minus 2. Now when I'm looking for possible zeros, nothing matters to me except the lead coefficient and the constant. I need my constant factors. 2 factors is 1 and 2. And I need my lead coefficient factors. And it factors 1 and 15, 3 and 5. So now remember, it's always constant over coefficient. So I'm going to set up constant over coefficient. So I'm going to do 1 over 1, and that would be both positive and negative. I'm going to do 1 over 15, both positive and negative. I'm going to do 1 over 3, both positive and negative. I'm going to do 1 over 5, both positive and negative. Now I'm going to do 2. 2 over 1, both positive and negative. 2 over 15, both positive and negative. 2 over 3, positive and negative. And 2 over 5. So those are all of my possible zeros. So you see right there, there are 16 possible zeros. And then I would start to divide. So that is the rational zero theorem. That tells me where I could possibly start. And now the next thing that you would be expected to do is to find a zero. So this is where you would guess and check, and you would synthetically divide, which you've already practiced doing. So I have f of x equals x to the third plus 2x squared minus 5x minus 6. On the questions on the computer, the first thing it's probably going to ask me to do is find all the possible zeros. So I'm going to do that. I'm going to factor 6. 1, 2, 3, and 6. And then my lead coefficient is 1. So my possible zeros are 1 over 1, 2 over 1, 3 over 1, and 6 over 1. All positive and negative versions of that. So I have 8 possible zeros that I can synthetically divide with, but that might take me a while. And since I have access to a graphing calculator, I'm actually going to look and see if I can find a zero inside of my with my calculator, because that would be a whole lot faster and easier. So I'm going to plug my function in. X cubed plus 2x squared minus 5x minus 6. Once I've plugged it into my calculator, you could go to your graph and look for it, but I'm going to go to my table. And I'm going to check and see if I see any zero. Well, there's one right there, 2. And it was on my list. And actually, there's another one. And actually, there's all 3. I know there should be 3 zeros. And there they are, -3, -1, and 2. So that would be my solution set. X equals -3, -1, and 2. So that would be my first step, is check and see if you can find them in your calculator, because that would be a whole lot easier. So let's try another one. And I'll show you what to do if you can't. I'll show you what to do if you can't find them in your calculator. So now I have f of x equals x cubed plus 8x squared plus 11x minus 20. To find your possible zeros, I'm going to set up 20. Factors would be 1, 2, 4, 5, 10, and 20. All of those would be over 1. So those are actually my possible zeros. So now I'm going to plug it into my calculator and see if I see zeros here. X to the third plus 8x squared plus 11x minus 20. I'm going to go to my table and see if I can see them. And I can. I think I can see all 3, but let's pretend that I can't for just a moment. Let's say I looked at my table and the only one I found was 1. 1 is a 0, because it says right here on my calculator it is. So now what I would do is set up my lead coefficients, 1, 8, 11, and -20, to synthetically divide. Now remember, make sure you have all of your descending exponents, and if you don't, you put a placeholder. I'm going to drop the 1. 1 times 1 is 1. Add straight down. Add straight down. Now, when I synthetically divided, I did in fact end with a 0. You should, because this is a 0. What is left is a new trinomial 1 degree down from where I started. So I started with x cubed, so this is going to be x squared. So those are the lead coefficients of a new trinomial, x squared, positive 9x plus 20. Now I have a trinomial that I can either factor or plug into the quadratic formula. And this one actually factors as x plus 4, x plus 5. Which means these two pieces are also zeros. So x equals -5 and x equals -4. So I found my first zero of 1, and these are my other 2. So my solution set would be -5, -4, and 1. So that would be how you find the zeros. I'll do a little bit more of this on another video where you actually don't have whole numbers, but maybe an irrational number, an imaginary zero.